So how does one go about designing a BMS? Well, before we can start designing, we have to know exactly what we're trying to do. And it's basically just a series of checks. Check that the temperature is within range, check that the voltage of each cell is within range, and check that the current is within range. That's it. If any of them go out of range, we have to turn off the battery, which can be done quite easily using MOSFETs. So let's give this a go. For the brains of this, I'm going to use an Arduino Nano and connect each cell to an analog pin through a potential divider. By selecting the correct resistors, I can keep the cell voltages right in the middle of the Arduino's ADC range. And by using such high resistor values, even if something does happen and higher voltage gets put through them, it won't damage the Arduino because there simply won't be enough current to do any significant damage. In order to measure the current, I'm going to be using something called a current shunt. And what this is where you take a known resistor and measure the voltage drop over it. Using Ohm's law, you can then calculate the current. In my case, I'm going to actually be using the drain source resistance of the MOSFETs because I know that in the on state, the drain source resistance of these particular MOSFETs is 17 milliohms. And to get 5-volt power to the Arduino, I'm going to use a DC to DC converter. I quickly whipped up a schematic in KiCad before moving on to building this on a perf board. The final thing to do was write some code and upload it to the Arduino.